Drugs are prescribed to cure a disease, but if the drugs are toxic in nature, it can cause a number of side effects. Because the drugs, being small, can go to different sites of the body, including target sites and non-target sites. On the other hand, there are new drugs that are a bit bigger than the traditional drugs, but they are quite sensitive to be degraded in our biological system. So a carrier is quite important. What will be the job of a carrier? A carrier will bind to the drugs, will transport the drugs to the target site, and then finally release the drugs to the target site. There are a number of carriers that can bind and transport the drugs to the target site, but we don't know the mechanism of those carriers, how they release the drugs. In fact, they're very inefficient to release the drugs. We have developed for the first time in the world pH-sensitive inorganic nanoparticles that binds drugs, carry the drugs, and also to release the drugs. How they release the drugs? Because they are very pH sensitive. Once they go to the target site, they are dissolved, because the target site has acidic compartments that helps to dissolve. And that is why we use these carriers successfully to deliver small molecule drugs, nucleic acid based drugs with excellent outcomes in cancer.
Hi, I'm Narayanan Ramakrishnan, currently an associate professor in School of Engineering. I'm also leading the micro nano devices research group, and we have a lab with the same name. We are actually conducting fundamental as well as translation research on microsensors, and we are trying to develop environmental sensors, especially to detect relative humidity or detect pollution and so on. In general, to manufacture these kind of microsensors, we need sophisticated facilities such as clean room, and also we need sophisticated equipments like mass cleaner systems. In the early stages of our laboratory, we did not have that much of resource, and to procure this kind of mass cleaner system was quite difficult for us. So we decided to build the mass cleaner ourselves. So we started with simple steps in building this machine, and over the last 3 to 4 years, we actually completely made a mass cleaner system which has features that are challenging and comparably better than the commercial mask cleaners, and at the same time the cost of these mask cleaners, or the production cost, is around 90% less compared to the market mask cleaners. Now we are looking forward to commercialize this machine. We are working on joint venture with the local industries through startup, and also with help of Malaysian government startup opportunities.
Due to global warming and overfishing, the world fish industry is under threat. Fish in captivity take longer time to grow and to mature. This has put huge economic constraints on fish farmers. Our brain is a very complex organ. It controls our physiology, which includes the reproductive and the growth axis. We have developed naturally occurring brain peptides that are safe and effective for advancing growth and maturation in aquatic animals. This invention has been patented. It will promote aquaculture, leading to food security and meet one of United Nations Sustainable Development Goals.
Hi, good morning everyone. Today we're going to talk about biodegradable polymers for future materials. In my group, we prepare cellulose from the plant biomass, which is, we are working on sago waste and oil palm waste. Cellulose are not dissolved in water, so we convert that to carboxymethyl cellulose and cross-link them with various methods to form three-dimensional network called hydrogels. Hydrogels absorbs a lot of water, so and this hydrogels has got porous structures like this, and it allows various active agents such as drug, fertilizers, metals, and dyes to be added into the cavity of the pores. The extent of cross-linking of the nature of a CMC determines the controlled release of the active agent. So these hydrogels are targeted for drug delivery system, as a biomaterial for tissue engineering and wound healing, for packaging materials, for absorbents in wastewater treatment, and fertilizer carriers, cum superabsorbents for agricultural industry. And these projects are funded by our government as well as external forces.
Here we have this form hydrogel for drug delivery system. Here we have vegetarian capsule made from CMC from palm oil waste.
The M-Dengue app was developed in collaboration with the Ministry of Health, particularly the public health group down in the district of Segamat, and it came about because of the concerns about the number of dengue cases that were occurring in Segamat, but in Malaysia generally. The M-Dengue app allows us to monitor potential breeding sites for dengue, and that's then reported to the environmental health officers. The environmental health officers have an opportunity to look at the sites and decide if they're going to actually investigate or not. So what happens is that an individual in the community can have the M-Dengue app on their mobile phone. They can take a photograph of a site that they think might be a dengue mosquito breeding site. They can send that to the environmental health officers. The environmental health officers can look at that on their mobile phones or on their websites, and they can decide on the basis of that whether they need to go out and actually take some action, whether they might need to drain the site or spray, or whether in fact it's benign and they don't need to deal with it. I think one of the most important things about the M-Dengue app from our point of view is, one, it engages community in thinking about dengue and thinking about dengue breeding sites, and the other is that it gave us an opportunity to collaborate more closely with the Ministry of Health. And it was important to collaborate with the Ministry of Health because of our relationship with them and the SECO MOU between Monash University and the Ministry of Health Malaysia.
This is GeneBlocks, the genetic board game designed to learn the central dogma of molecular biology in a fun and innovative way. Gamification is a term used to describe the usage of games element in a non-game context, for example, in education. We came up with this idea because students often complain that learning genetics is tough, and we always believe that learning should be made easy and fun. Research also showed that competition can trigger part of the brain that promotes learning. So what are you waiting for? Roll the dice now.
Technology and gamification is increasingly being used in higher education nowadays. So what we did was we found that gamification, or using games to get students to be interested in studying, is a very, very effective and useful way to teach some of the more difficult concepts related to biology and biotechnology. What we did was we actually created the first board game known as GeneBlocks, which is used to learn the central dogma of molecular biology. In this game, students will get to learn about the transcription and translation process in a very fun and interactive manner. So what students would be able to do is actually do or try to compete among each other and try to answer as many questions as possible and collaborate with their peers to actually understand about the central dogma of molecular biology. So this was started off as a very small project which was led by Dr. Jasmine, and it became a larger project which ended up for us developing an IP out of this. So please do join us and come and join and have a look at our this game board.
Hi, I'm Associate Professor Adeline Ting from School of Science, and I'm here to share with you about our research which was awarded the gold medal for ITEX 2018. Our project was simple. It has a simple aim, which is to discover a more environmental friendly approach to manage crop diseases. And our approach is through the biological approach, whereby we are sourcing for organisms as a substitute to the chemicals. Our research started with a series of tests in the laboratory and also potted plant tests in the glass house. And what we discovered is that among the many different types of organisms which we have isolated, there is one particular fungal isolate which is identified as Penicillium citrinum, which has shown a lot of benefits to the host plant. For example, it actually improved the growth of the plant, it also has good disease suppression, and it also produces a lot of antifungal compounds which were useful to inhibit the growth of the pathogens. So we can conclude that Penicillium citrinum is indeed a very ideal bioagent, and it has lots of potential for biofungicide development. It also has good potential to be translated for use against other types of pathogens for other types of crops, mainly because the antifungal activity by Penicillium citrinum is very broad spectrum. So to conclude, I find that our study has shown that ultimately what we have discovered here can be used as a green solution to the agricultural and environmental issues. Thank you.
Hepatitis B vaccination has been proven effective in reducing the incidence of acute hepatitis B, which remains a major health issue globally. And early detections of hepatitis B virus can substantially reduce the overall cost of medical treatment. A biosensor has been developed for the diagnosis of hepatitis B virus infections. These biosensing mechanisms relies on the functionalized hydrogels that detects the hepatitis B virus serological marker via a volume change. The detection mechanism of this bioconjugated hydrogel is based on the swelling abilities of hydrogel in the presence of target analytes. The weight change in the hydrogel corresponds to the concentration of analytes detected. This labor-free detections of hepatitis B virus by the biosensor is rapid, inexpensive, and highly specific.
In Malaysia, there are about 55,000 registered functionally deaf people. However, it's believed that there are many more who have yet to be identified. Now, deaf individuals have been shown to have a lower health literacy compared to their hearing counterparts, putting them at a higher risk for health problems. Furthermore, healthcare professionals themselves are generally unprepared to understand the needs of deaf patients, as they lack training to provide linguistically and culturally competent care for these patients. Now, to add to this problem, the ratio of a deaf person to a sign language interpreter in Malaysia stands at 1:800. Thus, as long as this communication barrier is not addressed, health inequalities faced by the deaf will continue to worsen. Now, this is where the DITE app could be useful. Now, DITE stands for Deaf in Touch Everywhere. Now, DITE is designed to help healthcare individuals schedule and book a sign language interpreter on demand on basis of their convenience, pretty much like how you book a Uber or a Grab. Now, this app leverages on the free video calling services that are available out there, like FaceTime, Skype, and all. So what a deaf individual needs when they go for their medical consultation is a smart device. So currently, we at Monash, Malaysia are testing out or evaluating DITE in a simulated medical consultation to ensure that it serves as an effective way for deaf to communicate with healthcare personnel. We sincerely hope that DITE will ultimately improve health outcome of the largely underserved community.